In these videos I'll be making, all of the problems that we'll be working through are coming out of the Math 1010 lecture notes. So let's get started. This video is going to be about section 1.1, which is all about graphs. Before we get started on graphing things, we need to talk about some definitions. So first thing that we want to talk about here is, it says blank is a two-dimensional plane formed by the intersection of a blank x-axis and a blank y-axis. So a coordinate grid is a two-dimensional plane formed by the intersection of a horizontal x-axis and a vertical y-axis. The coordinate plane is divided into four parts called quadrants. And so we can see below that here is quadrant 1, 2, 3, and 4. And you can see that there is the y-axis going up and down and the x-axis going left to right. So the x-axis is the horizontal number line on the coordinate plane, and the y-axis is the vertical number line on the coordinate plane. So an ordered pair is the next thing that we need to talk about. And this is a point. So an ordered pair is a pair of numbers used to show the position of a point on a coordinate plane. The first value of the x-coordinate is the x-coordinate, and the second value is the y-coordinate. The point in which the two axes intersect is called the origin. The origin has an x-coordinate of 0 and a y-coordinate of 0. The ordered pair for the origin would be 0, 0. All right, and we'll skip over some things here. You can always go back and work on those things that we skip on your own. Okay, so this next part, we need again to get some more definitions in here. So each solution to an equation with two variables creates an ordered pair. For example, solutions to 3x minus 4y equals 12 are ordered pairs, x, y, that make the equation true. The graph of any first-degree equation in two variables is a linear equation. All right, let's do some practice here on how to graph some of these. So we're going to start off by having a table of values, and you can see here that I have some x chosen as -4, 0, and 4, and we'll go ahead and put those in place of x in the equation given and figure out what y is. So I'll have 3 times -4, put in place of the x, minus 4y equals 12. And so I have -12 minus 4y equals 12. So we're trying to isolate y, so let's add that 12 over. And I'll get -4y equals 24. And now I just need to divide both sides by -4. And we get y equals -6. So we end up with this point, an ordered pair of -4, -6. All right, if we put 0 in here, this one is a little bit faster to work through. So if we do 3 times 0 minus 4y equals 12, Well, 3 times 0 is just 0, so we can get rid of that part, and we just need to divide both sides of the equation by -4. So y equals -3. So we have -3 is our y, and our ordered pair would be 0, -3. All right, let's look at one last point here, and then we'll graph it on the grid. Let's put 4 in. So I'll have 3 times 4 minus 4y equals 12. So now I have 12 minus 4y equals 12. And this time I need to subtract 12 from both sides, which is going to give me -4y equals 0. And if I divide both sides by -4, I see that, well, anything divided by, if we have 0 divided by a number, we get 0 for our answer. So 0 is our y that comes out here. And so we have the point 4, 0. So let's place these on here. And as I do, I want to talk a little bit about some of these points. So this first one, -4, -6. So to the left, -4, down -6 will be here. And then this next one, 0, -3. So over 0, down -3 is here. And this crosses the y-axis at -3. And so that means that this is going to be our y-intercept. And we'll talk about that a little bit later. And down here are 4, 0. So over 4, up or down 0 is there. And this time we can see that's on the x-axis. And so that is our x-intercept. All right, and those are important parts of the graph, and so that's why I tell you what those are. And then you'll just need to go ahead and connect the dots on this. Draw your line through this. Sometimes it's easier than others on here. All right. Goodness, well, not quite through all of the points there, but I think you get the idea. So that would be what the graph of this line looks like. Next, we want to talk about a solution to an equation. When we ask, is this point a solution to the equation, what we really mean is this point on the graph of this line? And so if we were to graph this, would this point be on it? Well, you could do this graphically, or you could do it algebraically. So remember, this is our x-coordinate, and this is our y-coordinate. And so I'm going to substitute those values in place of x and y here, so we can see if it comes out to be a true statement, it is a point on the line. If it comes out to be a false statement, then it's not a point on the line. So here I have -5 times x, which is -6, plus 2 times y, and y is -20, and then equals -10. So let's go ahead and simplify this and see if we come up with a true statement. So -5 times -6 is +30, and then 2 times -20 is -40. And we're trying to determine if that equals -10, and 30 minus 40 is -10. So since -10 equals -10 here, that means that yes, this is a point on that line. It is a solution for this. Okay, let's keep going on, talking a little bit more about some definitions here. And I talked a little bit about these above, but let's go ahead and define it in this way as well. So the y-intercept, all right, like I said, that's an important part of a graph. So the y-intercept of a linear equation is the point where the graph of the line intersects or crosses, right, the vertical x or y-axis. The x-intercept is where the graph of the line intersects or crosses the x-axis. Okay, so we can find our intercepts, and we can use by graphing to do that. So one way that we can set this up to do that is, let's just make a table of values here. One where we're going to put 0 in place of x, the other where we're going to put 0 in place of y. So let's see what happens when we do that and what we come up with. So on this first one, we're going to do 3, and in place of x, I'm going to put 0. So 3 times 0 plus 2y equals negative 18. Again, 0 times anything is just 0. So left to do would just be divide by 2. So y equals negative 9. All right, so we have this point here, 0, negative 9, and this is going to be our y-intercept. All right, so when we let x equals 0, we find our y-intercept. When we let y equal 0, we're going to find our x-intercept. So let's do that next here. So this time I'll do 3x plus 2. This time we're putting 0 in place of that y. So 2 times 0 equals negative 18. So we need to divide both sides by 3, and we get x equals negative 6. Okay, so we have the point negative 6, 0. And this is our x-intercept. So let's go ahead and graph this on the grid over here. Got 0, negative 9, so over 0, down 9 is going to be here. And then negative 6, 0 is going to be here. And then when we connect those two dots together, we will have the line on here. Let's see. Okay. So that's another way that we can graph it. So table of values, and then on this one, finding those intercepts to be able to figure out what the graph looks like. Right? So those are great ways to do this. All right, so let's see, a horizontal line of the graph of a linear equation in the form y equals a is where a is a real number. The graph crosses the y-axis at the point A. And similarly, vertical line, right, in the form of x equals b, where b is a real number, the graph crosses the x-axis at the point B. So specifically, if I write these out as an ordered pair, right, we're going to have, so when y equals a, right, we have, well, we're going to just leave it like that for right now. Sorry. Okay, so a couple of things that we're going to do here. We need to graph, and this up here is going to kind of help us know. So we have y equals some number, kind of like this form that we have up here. So that's going to be a horizontal line at negative 3 that we have there. So one way that we could graph this, let's see, I'll graph it here. And I'll just put a 4 by it so we remember this is number 4. So y equals negative 3. If we go down 3 places on the y-axis and then draw a vertical line, or sorry, a horizontal line there, that would be the graph of it. Now for number 5, we need to graph the line x equals negative 6. And again, if we look at what we said here, x equals some number, right? That's going to be a vertical line. So let's see, we'd have something like this. And 1, 2, 3, 4, 5, 6. And then we have a vertical line right here at -6. So that would be our graph for that. All right, and then you can also tell what the equation of the vertical and horizontal lines are just by looking at one point. So the equation of the vertical line here is, let's see, so I'm going to we're talking about a vertical line here, right? And this is where we are talking about up and down, so it's like this, all right? So that means we're going to have x equals some number is going to be the equation for this. So let's see, I'll put it over here, x equals, and then if we look at the point that's given, well, we see x equals -2. And so that is the equation of a line, just x equals -2. And similarly, right, the horizontal line, the equation for a horizontal line through that same point, this time we're looking at the y coordinate, which is -10. And so our equation of this line is y equals -10. All right. Here we're going to practice plotting some points given some values here. So if I put -2 in place of my x here, remember that I'm going to have, on this first one I'll write it out, y equals, and then in parentheses, -2 all squared, right? Which is different than y equals -2 squared. All right, -2 squared written on this top way is -4, where this bottom one that I have written is +4. And that's really what we're doing on this. So I want to make sure that that's clear. We're taking that, all of that x value, and squaring it. So that is going to give us a +4. All right, and if we keep doing that, put -1 in place of x, and we get -1 all squared is just 1. Put 0 in there, 0 squared is 0. Put 1 in there, 1 squared is 1. Put 2 in there, 2 squared is 4. So now we can plot these points on here. We can see we have over -2, up 4, over -1, up 1, 0, 0, 1, 1, and 2, 4. So you can see it's making this shape that is a curved graph, and so it's kind of like a U-shaped graph. So it shouldn't come at a point down here. It's U-shaped. Okay? And I want to show you, looking at something that we, if we look at our Desmos, let's see here. So if we go to that Desmos graphing calculator, we can kind of see here's a graph that we came up with for it. All right. Now the next one is going to ask us to graph y equals x to the third. And on this one, I just want to make sure on these next few that it's what we're trying to figure out is the shape of the graph, what it is doing. And so we can see that y equals x to the third is going to be this kind of S-looking thing, right? And so just make a rough sketch on that where it asks you to graph y equals x to the third. And this is called a cubic graph. All right, if we look at the next one on there, it asks us to graph y equals the square root of x. And notice that the square root of x has a starting point, right? And then it goes up and out forever in that positive direction. And so all square root graphs have that same kind of look to them. All right, so just make a rough sketch on there for that one. The next one is y equals the absolute value of x. Now this one does come down at a sharp V. All right, so it's not rounded like the y equals x squared is. It is a V-shaped graph. And so again, make yourself a little, you can fill those in, making a little rough sketch of what we have there. All right, and then this last one is this rational function. And on this one, you can see it's kind of a different graph because it's kind of in two different places here. And that's because look at how x is in the denominator. And we can't divide by 0, so that means our graph can't occur here at 0 or on that y-axis. Okay? So that's why that's happening. And you can see how it's getting really, really close to those axes too. And we'll talk a little bit more about those later on. Those are called asymptotes. And so that is a good thing to keep in mind for later. Okay, so hopefully you got those kind of drawn in here on these next few. So this y equals x squared, also put down here that this is a quadratic graph, or sometimes it's called a parabola. That next one here, like I said before, this is called a cubic. All right, and a cubic's always going to have that kind of shape that goes something like this. All right, I'm just going to let Desmos do it. All right, and then this one, like I said, is a square root. So the name of it is square root graph. Then this one is an absolute value graph. And I would mention on this that just to make sure that you remember that it is a V-shaped graph, like we said. And then this last one here, this 1 over x, is called a rational. All right. Remember, we have the word rational. It means there's some kind of fraction involved there. All right, so you can take some time and go back through and, sketch these out. But what I want to make sure that you know is the general shape of those, okay? And just how to use a table of values to be able to graph something. All right, so let's kind of go back and review over a few things that maybe you should know for what we're going to be doing next. All right, so a variable is just basically the letters, right, that are found in equations that we're dealing with. The coefficient, those are the letter or the numbers in front of the letters, right? So like this 3 is the coefficient of 3x. Now terms, so if we have some polynomial things here, terms are connected by adding and subtracting. All right, so that's how we have those. And then an expression is the groups of terms are connected by add and subtract here. And notice that there's no equal sign in that. Okay, expressions don't have equal signs in them. But equations is the next thing we need to talk about. Equations are mathematical statements that are equal, so they will have an equal sign in them. All right, so there are some things here that I would encourage you to go through. Identifying these as equations or expressions, and then also do this review of fractions, just to make sure that you're remembering how to do it. And if you don't remember for sure how to work with fractions, go ahead and look up a YouTube video about those so you remember how to do those. And then another thing that I would say on this 1.1 is graphing these table of values. So go through and do this, and I'll leave that for you to do on your own.